Okay, hello everyone. Hope you all did fine in your exam, and NEET exam is just over as we know. So to give it a just a deep analysis about how the mostly expected toughest section of this paper, that is physics or chemistry, in comparison to biology, how was this paper this time for physics at least. So let's start discussing that part by solving some of them here itself. Okay, so I'm starting with the very first question. I think you can see the question paper is there in front of us. So the very first question says that you have to find out the current passing through the battery in this given circuit, right? So I think the question is pretty much straightforward. So if I tell you from my side that how we have to start thinking about this case, then I think we can do one thing. We can pick a pen here and just get started. So I think you can see that this 5 ohm, this one, this one, this one, and this one can be first of all easily simplified, right? Because 5 ohm and 2.5 ohm are going to be in series, and that is going to be in parallel with this 6 ohm, and that again is connected in parallel with this 4.5. So I think first we have to find out the parallel of these, uh, I should say, 5 resistors here, so that we get some equivalent of them. So if I ask you what is the equivalent of these three, so how do you get the answer for this? Okay, so let me just ask you, this is 5 plus this becomes 7.5, this is 6, this is 4.5. So what kind of answer can we expect for this? I think what we are going to get, I need some place to start writing. Okay, so yeah, let's start writing here itself. Okay, how do we annotate this? Okay, yeah, this one. Okay, so there are three resistances. One is 4.5, other is 1 by 6, the other one is 7.5, because that is the formula for R equivalent of such resistances, right? So 1 by R equivalent of these 5. So how do we discuss this number? I think we can write it as 2 by 9 plus 1 by 6 plus 2 by 15. So if I try to take the LCM of this, I think the LCM should be 3 and 2 are coming from this, 3 and 5 is coming from this, and 3 and 3 is coming from this. So I think 3 into 3 into 2 into 5 should be the LCM of this part, because at least that much power will be required. So 9 into 2 18, 18 into 5 90. 90 is the minimum we can have as a common factor, common multiple of these. So if that is the case, so I think once I take the LCM, so 2 will be multiplied by I think 10, so that should be 20 from this side, and for 6 it will be 15 times, so it will give me 15 here, and then for this one I think it should be multiplied by 6 times, right? So 6 times will give me 12, so that gives me at last I think 27 plus this, that gives me 47 divided by 90, right? So my R equivalent turns out to be 90 by 47, right? Now let's get back to the question and see again what are the remaining things. So yeah, we can see that 1 by 3 and this 1.5 and 5.5 are there in series with this. So if I tell you, the overall total resistance for this case will look like 1.5 plus 5.5 plus 1 by 3 plus 90 by 47 is what we are expecting, right? So I think this turns out to be 7, and if I roughly add it, this is 0.33, and how much this can be, I think somewhere around, if I try to approximate it a bit, I can treat it to be somewhere around 1.9 or something, right? Can I do that? Because the exact second multiple of this will give me 94. So 94 gives you 2. So 4 less than that will give me somewhere around 1.9 approximately. That is a very grave approximation, but let's take it as such. Hai na? So was 7.33 plus 1.9 gives me roughly 9.23, right? And the battery was for how much volts? So the battery was for 5 volts. So 9.23, and that roughly takes me towards uh, current being V by R total, right? So the voltage has been given as 5. This is roughly 5.23. So the nearest answer we can get in this case will be somewhere around zero point 0.5. So I think that should be the correct answer for this case. And if you take it as a, how much did we calculate here? Okay, 1 by 3, 1 by 9. Let's check it again, है ना, so that we don't make a mistake here. Approximately nearly 2 we calculated it because of 3 being in parallel, and then these are in series, and I think we did not miss any part. Yeah, so I think this answer seems totally fine. So let's move on to the next question. This looks like to be having an answer somewhere around zero point 0.5. Okay, so now let's jump to the second question. So second question says the electric field in the plane electromagnetic wave is given as this. Okay. Okay, electric field will be in one direction. It is about the total electric field. So I think it has an expression which is given there. Then the expression for the corresponding magnetic field will be. As you can see, this is an expression of electromagnetic wave, which if can be written in the proper form of sinusoidal wave. So I think we can go on to write it as, okay, let me just write it for you. The numbers are 65 and 1.5 into 10 to the power 9. Okay, so let me take you to some space. So that was 60 multiplied by sine of, and that number was again 5x plus 1.5 into 10 to the power 9 into t plus pi by 2 if I can do here, right? You know, this is all going in z direction because it is already given E is in z direction. Okay, so according to this, how do I think that this wave should be propagating? Is it a wave which is propagate? I know definitely it is in the x direction, but is it a negative direction or is it a positive direction of propagation? What can we classify here? You know that omega t minus kx kind of waves do travel in a positive direction, right? Positive direction of the x-axis if we take. So we definitely know if it is going to be plus in between them, then definitely the answer in this case is negative. So the direction of propagation of the wave in this case is minus I cap, right? What we can confidently say by taking it as the negative side of the x-axis. I hope you are getting this point. So once we know this, so definitely we know the wave is propagating this side. This is z-axis. So I know I have my basic equation that E is equal to B cross C, right? Something like this triangle, right? E, B, C. So E is equal to B cross C, or if I have to discuss, let's say, because C is there with me, the electric field is there with me, so I have to discuss, let's say, B. So how do I find B? It is C cross E, right? So C cross E can give me idea about B. So definitely I need to see, I need to properly apply my right hand thumb rule, so that gives me direction of B as positive y-axis. You can see that if I properly apply my right hand thumb rule, so this direction will only obey the consistency. So I think I should start seeing the questions options. So I think two of the options have been eliminated. X and Z cannot be the answer. So okay, now what about this number 60? Will it be remaining exactly 60, same as what was the amplitude of electric field? I think we can easily say that that won't be the case, because we know there is a relation between E and B, which is given by E by B should be equal to C. So I think the magnitude of B will be E by C, right? So that should be 60 divided by, there will be a number which has to go like velocity of the electromagnetic wave. So how can we find the electromagnetic wave's velocity? This is k part and that is omega part. So if omega and k are there with me, so I think we can write velocity as omega by k, right? So omega is there as 1.5 into 10 to the power 9 and k is given as 5 in this question, right? Right, so I think that's a perfect case, and that gives us idea also that this is turning out to be 3 into 10 to the power 8 only. So there is no medium or any kind of activity here, it is purely a speed of light, that is what we are witnessing here. So if V is now available with us, so can I say that magnitude of B will be 60 divided by 3 into 10 to the power 8. So that should give me what? 20 into 10 to the power minus 8. So I think the answer should be 2 into 10 to the power minus 7. So I think let's check that. So 2 into 10 to the power minus 7. I think the best answer in this case would be if I can pick the second one. Okay. So let's move on to the third question now. A pipe open at both the ends has a fundamental frequency of F. The pipe is now dipped in vertically in a water drum, okay, up to half of its length. Then the frequency of the air column is now equal to, okay. So I think it is fundamentally testing us on an understanding of the organ pipes. So I think earlier it was totally open. So in this case, the frequency that we were fundamentally seeing was F. You know, in the fundamental case, this is the fundamental case that happens here. So L seems out to be lambda by 2, right? And as same sound is getting used in the second case also, where the water is dipped till half of the length. So half of the length is now not available for the air to form a stationary wave in the air column. So I think we can say that in this case the length will be L by 2, right? And if the length of the column, that is the new length L dash, which is available for air, is half, so can we say that from the previous relation that it should be, if the same wave with the same frequency, I think the same frequency cannot be used, but if I have to make it resonate it here, so this should become like a node and that should become like an anti-node. So if I have to form, and I think particularly they are asking me about the fundamental only. So fundamental frequency of the second air column will be what? Fundamental frequency will be, let's call this to be lambda dash by 4, because you can see that the gap between the antinode and node is lambda dash by 4. So that is looking like to be L by 2, right? Which you can say is nothing but because L was equal to lambda by 2, so L by 2 will be lambda by 4. So can I say that lambda dash is turning out to be lambda only, similar to the previous case, right? So can I say in this case, if the wavelength that these two cases are using is same, and the sound definitely is going to travel at the same speed, so I can say the frequency also is not changing for both the cases. So whatever fundamental frequency was getting witnessed here, the same thing will be getting used over this case as well. I think you are getting the case. So let's see the answer. So there is this option, that is 3, which says that fundamental frequency of the air column in this case is also going to be equal to F. Okay, let's see the fourth question now. Okay, this question says that there is a electron, mass and charges are given, moving with a speed given to you, is injected into a magnetic field whose magnitude is there with us, perpendicular to its direction of motion. So the magnetic field is perpendicular to the direction of motion. We wish to apply an uniform electric field together with the magnetic field so that the electron does not get deflected. So I think this is very easily the case of balancing of the forces. So if let's say the electron is traveling in some direction and let's say the magnetic field is present perpendicular to it, we know electron is there and it has a negative charge, so the magnetic force is given by Q into V cross B, right? So if we just apply V cross B by the right hand thumb rule, whatever direction we will be getting through it, exactly negative of that has to be taken because we know this charge is negative, right? So if I apply, this is V, this is B. If I apply my right hand thumb rule, I am going to see the force coming on that direction, but I know the answer is exactly opposite. So the answer for the magnetic field is inside. So that is minus K cap. You can see that, right? So definitely if that has to be countered by the electric force, so I think I should apply a electric field in this direction, because okay, not in this direction, just sorry for my mistake. If I know I'll apply electric field in this direction, that is minus K cap only, then only I'll be getting a force QE, which will be in this direction, because Q is negative for this case, right? So definitely my electric field will be also present in which direction? Minus K cap, right? And if I have to talk about the magnitude of it, you know, Q into E has to balance Q into V cross B, and everything is perpendicular, so I can drop these vectors from everywhere. I think I can perfectly use this equation QE is equal to QVB, which gives me nothing but electric field magnitude as VB, right? So that means if I am given with the values, I think I can easily find them. Speed is there with me, the magnitude of the electric field also. So I think 9 into 10 to the power minus 4, that has to be multiplied by C by 100. So C by 100 will be roughly around 3 into 10 to the power 6. 9 into 10 to the power minus 4 is going to give me 27 into 10 to the power 2. Let's see if such an option is there. Okay, let's see if C by 100. Okay, we have used proper value of C by 100, I think yes, and the magnitude of V is there. B is also 9 into 10 to the power minus 4, that is also in SI unit. So what should be the answer? So I think we are getting near to the correct answer. As we can see in the third and fourth options, 27 into 10 to the power 2 is present, which is what we are also seeing. So definitely we are seeing that this option is what most appropriately is going with the discussion that we have done till now, because electric field also is coming to be parallel to the, okay, not parallel actually, the diagram over there says, okay, just a second, where is the undo thing here? Okay, edit, okay, right. So I think the electric field direction is in the minus k cap, while the force of magnetic field was also in minus k cap, but the direction of magnetic field was in y cap, the j cap direction, right? So I think we should say that electric field is perpendicular to this and its magnitude is this. So 3 should be the best answer as per our discussion. Okay, let's go towards the fifth question now. In a certain camera, there is a combination of 4 similar thin convex lenses arranged axially. Their axis seems to be just common because they are arranged as a combination of convex lenses axially. Their axis seems to be exactly coherent, right? Same axis they are using. Then the power of the combination and the total magnification in comparison to the power and the magnification for each lens will be how much. So I think power is very basic here. So if 4 lenses are being placed back to back with the same axis, we know if everyone had a power of P and if they are thin lenses, so that this size also seems to be negligible in comparison to the sizes or the apertures. So we know that powers can be directly added. So V powers, if they can be directly added, so the power net for this case should be 4P, right? If that is the case, so 4P is what I am getting for power at least, and out of these two, where I am getting 4P. And if I have to talk about magnification, we know that magnification depends on what? We also know that magnification depends on HI by HO, right? So HI by HO, that magnification, how is it explained here in terms of power? Can we explain that number? Okay, so just give it a thought, ki how is this dependency going on the power here in this case? Let's see. Okay, so yeah, I think we know basically there is a basic lens formula that we already know, that is 1 by V minus 1 by U is equal to 1 by F. So I think 1 by V, if this thing I just multiply with a U, so I get a equation like this. So U by V turns out to be U plus F divided by F, right? So I think V by U is what we are getting as F by F plus U, right? And that is nothing but our magnification, right? If you know the basic formula, the HI by HO is also equal to V by U for the case of lenses. So if we know that this case has become like a case of 4 times the power, right? So 4 times the power, can I say that power is defined as inversely proportional to the focal length for the lenses? Okay. So if that is the equivalent length that we are discussing, so can we say if the power has become 4 times, then the focal length must have become 1/4. So I can say the equivalent power focal length is behaving like f by 4. Then only it can become 4p, right? So if that is the case, can I say if something like this is going to happen here, so can I also go on to write this as 1 plus u by f, right? Okay, so instead I know because same u has to be used in this case. That is, if you just want to analyze the focusing power of a lens, then generally we do expect this to be going almost like for the same position of the object, right? So if same position of the object will be exactly used here, so I think what can be the discussion here about the focal length in this case, that is almost m is going to do a job of okay. So I think, yeah, we were discussing about key this has to be the formula that can be used to start with. Okay, but simultaneously, is there anything that we already know, that magnification of individual lenses? If we know, definitely we know that magnification is what, hi by ho, that will be happening for the first lens. Then for the second lens again, it will be like the hi will behave like a object, and then it will be a image dash that will be forming after the second diffraction. So this one will be there. So we know definitely if we want to analyze the final quantity, I think if hi is the first image, hi dash is the second one, hi double dash is the third one, hi triple dash is the last one, then we are only going after this number, right? Hi triple dash, right? So hi triple dash by ho is what we are looking effectively to give them total magnification. But we know this number can be easily achieved by multiplying these individual magnifications, right? So if that is the case, we know the individual magnification in this case is nothing but, because they are same, so m is what is going to come in this case. So we know definitely m to the power 4 is what will be the answer for the magnification. So I think we need not go too much into the formula here, and we can just directly give the answer as well. So I think for this case the answer should be best given as 4. Okay. Okay, now let's come to the sixth one. This is uh, 2 ampere of current is flowing through two different small circular coils having the radii as this. The ratio of their respective magnetic moments will be, if okay, two different circular coils are there, their radii are different, but same current is flowing through them. So the ratio of their magnetic moments. I think this is very easy question. So I think how can we start treating such a question? So that question number 6, we know that magnetic moment is given by the formula, that is I into area is what they are going to be possessing. So that magnetic moment will be depending on these quantities, as it is dependent on the product. So we know that for the first one also, then the second one also, the currents are same. So it's largely about the discussing that number about the moments m1 by m2, which should be um, what, I will get cancelled. Okay, just a second, I don't know why it is going haywire. Okay, yeah, I into area of the first and I into area of the second. So these two things are just going to cancel out. So a1 by a2 is nothing but 1 by 4, as the ratio of the radii will 1 by 2. So area will be proportional to the second power of it. So we definitely know the answer is going to be 1 by 4. So let's see that option here. So yeah, we can see it here, and that is the answer in this case. You simply had to use the basic definition and take the ratios, right? The magnetic moments are dependent on the product of the current flowing through them and also the area that they are possessing actually at that in that geometry. Okay, so that basic definition is what was supposed to be used in this case. So now let's just jump on to the seventh question, right? So I'll be discussing totally 10 questions over here in the very first video that we are doing here, right? So let's first of all sum up, and then we'll continue discussing the other sets. Okay, so a constant voltage of 50 volt is maintained between A and B. Okay, and then the current through the branch CD will be what? Okay, so in this case 1, 2, 3, 4 are arranged and 50 is what we are supposed to give. Okay, so let me draw the diagram again here. So I know this resistance is 1, that next one is 2, this one is 3, and this one is 4, right? So we are supposed to give the answer for this branch, right? So and the voltage applied across all these resistors overall is 50 volt is what is given, right? So how do we discuss such questions? So I think we can assume this to be 0 volt, so automatically this becomes 50. So if I have to solve such a question, I'll definitely assume that there has to be a voltage because it is connected by a pure conductor here. So we can assume some voltage over this place which we call as V, and the potentials for them will be just equal. Okay, and if I have to apply something here which I can easily use, I can apply the Kirchhoff circuit law at least, right? Or the current law. Current law is better, I think, in terms of all, assuming all the currents to be outgoing and summing them to be equal to 0. So if I treat this number as I, so I know I plus V minus 50 by 1 plus V minus 0 by 2 is going to be 0, right? And if that is the case, then let me treat it. Okay, and the same current, if I write it from the other node, that is D part, I know that if I is the magnitude, right? Should I assume it to be a magnitude or should I call it to be a like a direction kind of thing? I think we can see that, but let me write the other things basically. So V minus 50 by 3 plus V minus 0 by 4 plus something with respect to I, because that same I is going to enter from this side also. So because we can see from the diagram it is coming like inside. So if I have to create an equation here, can I basically just go on and write this whole thing as because in this new diagram we are expecting the two currents to be outgoing, that is this one and this one, but one is looking like incoming. So I think it is better if I treat it like I equal to I, because if I'm just going by the diagram here itself, so here I was assuming all these currents to be outgoing, so I summed it up all to 0, but in this case this summation is for the two outgoing currents while I is appearing in the diagram to be an incoming current. So if I make use of this equation over above equation, I think I can easily solve that one. So V minus 50 by 3 plus okay, so V minus 50 by 3, V by 4 plus V minus 50 by 1 plus V by 2 should sum out to be 0. So if I try to solve this equation, I have done nothing but I have substituted the value of I over this place, so that only one variable is left. Okay, so can I write this as V minus 50 into 1 by 3 plus 1 by taking V minus 50 as common from these, and V by 4 plus V by 2, that can be written as 3V by 4. So that becomes the overall equation. So what should be the answer here? V minus 50 into 4 by 3 plus that sums out to be 3 by 4V. This should be 0. Okay, if I take the LCM of this here, I think that will be 12. So that will be 4 times of this. So 16 times of V minus 50 plus 3 times of this will be 9V should be equal to 0. So I think if I sum it all, so it will be 25V, 9V and 16 will be 25V is equal to 50 into 16, right? That is what I am getting. So I think the answer for V should be 16 into 2, so that should be 32 volt. Okay, if that is available, so can I calculate the value of C now? I have to just do nothing but I have to put the value here to get the value of I. So that value is V minus 50 by 3 plus V by 4. That is nothing but 32 minus 50 by 3 plus 32 by 4. that gives me minus 18 by 3 will give me minus 6, and that will give me plus 8, so that should be a 2 ampere. So I think that should be the answer for this case, and 2 ampere if there is an option, so that will be the answer for this question. Okay, let's go to the eighth question now. Two gases A and B are filled at the same pressure in separate cylinders with movable pistons of radiuses A and B. Okay. On supplying equal amount of heat to both the systems reversibly under constant pressure, the pistons A are displaced by 16 and 9. Okay. If the change in their internal energy is same, then the ratio of RA by RB will be. Okay. Okay. So for it's like a isobaric process, because under constant pressure is what everything we are doing here, and they are completely different cylinders, and gases may be different, right? At the same pressure were initially filled in separate cylinders with this. Okay, on supplying equal amount of heat, if the change in their internal energy is the same, then the ratio of RA by RB will be. Okay, let's try to see the situation here. Okay, so let me just keep the question available so that we can use the facts here also. Okay, so this is a cylinder A, this is a cylinder, this has RA, this has RB as the radius, right? And there is a piston somewhere in this one also, and there is a piston over this one also. They were initially at same pressure. P initial, let's say P naught was there, and then there were two gases. The gases are different, so that can be seen from the names also, A and B, although they are the names of the cylinder, but let's assume we are calling them as different gases. Okay. So now if they are subjected to, they are given equal amount of heat, right? So under constant pressure, then they are displaced by these numbers, 16 and 9 centimeters. So the change of internal energy is what also we are saying. So Q is what we are supplying here. Same heat is getting supplied over there. So once we supply them heat, this will try to increase their internal energy, but as we saw, the change in internal energy finally should also be same. So how that might be happening, and all that is happening at the constant pressure. So first one is getting displaced by 16, while the other one is getting displaced by 9 centimeter, right? Okay, so if I try to apply the case of Q is equal to delta U plus work done by the gas, that is the first law. So I know in the first case Q is same for both the containers, and delta U is also given as same for these two. So I know the work done is indirectly also going to be coming same for both the gases, because this one is also same, this one is also same, so their subtraction is also going to be same. So for work done by the A and work done by the B are going to be nothing but exactly same, right? If work done in both the cases is same and it was all done at the constant pressure, so I think the change in volume has to be also okay, not change in volume. It's about the work done being same, right? The work done gets same when P1 V1, that is PA VA, should be equal to PB VB, right? And we know, because that formula we can directly apply, or we can say change in volume here, because it is a change. So definitely, because the pressures were initially also common, so P naught, which will be maintained throughout, so this is also not participating too much in the discussion. So change in volume should be common. That was what I was trying to say, ki change in volume cell also has to match. So if that is the case, we know that pi RA square is equal to pi RB square and multiplied by the length. Length in the first case is 16, and in this case is going to be 9. So can I say RA by RB is nothing but whole square should be equal to 9 by 16. So can I say from this that the ratio that they were asking RA by RB should look like 3 by 4? Okay, so let's try to see that. Okay, so that is one option that is matching here. So I think the answer for 8 should be C. Okay. So I think questions are very normal till now. So we will try to look at the other questions also. Let's see two more questions for now for this video, and we'll keep the series very segmented to capture all the 45 questions here. Or I think I can make exact 5 parts for discussing all the 45 questions. I think this will be the last question for this particular video. So yeah, the question says here that a container has two chambers of volume V1 and V2. Okay, a container has two chambers of volumes V1 being 2 liters and V2 being 3 liters separated by a partition of thermal insulator. The number of moles are also given as in the first one being 5 and the second one being 4 moles of ideal gases, right, at a pressure of 1 atm and 2 atm. When the partition is removed, the mixture attains an equilibrium pressure of. Okay, so in this case, I think once we allow, and it was a thermal insulator initially, right? But once they will mix, so definitely what will happen? There will be a exchange of all the kind of energies, the things will be mixing up. So what basic formula can we apply, right? Because we know uh, that in this case, once they are mixing together, so all the energies also are available here inside them, and the number of moles are also going to be just combining together, and they will be attaining a final equilibrium temperature also once the mixing is totally done. So I think everything is just very fine in this question, right? So let's try to see the case. So let's try to write it down. Where is that page? Where did it go? Okay, somewhere, yeah, yeah, this place we were writing. So let's write about this question. Two gases were earlier held back from each other by using some kind of a partition which was thermally insulated, right? So definitely I know कि once you remove this insulator from here, the gas will start mixing, right? Because of maybe the temperature difference also is leading them to exchange the heat or things between them. Internal energies will also get some subsumed in this case. So whatever internal energies they will be earlier possessing, that might be the reason for because their concentration or the fraction differences are also there, right? The partial fractions are also, and initially one gas was not available here, the other was not available here, so they will start diffusing and to create a like a miscellaneous mixture which is quite uniformly distributed, right? So I know that U1 in this case will be written as P1 V1 into F by 2, right? Why that is the case? Because we know F by 2 nRT is what we call as internal energy of the gas, right? So that can be also written as F by 2 P1 V1, right? If that was the initial case and that other one was F by 2 P2 V2, right? So that is also the case here, and once they mix, so we know that whatever will be the total internal energy, that will only be the summation of this because of just some kind of exchanges of energies between these two gases, but energy is not getting lost anywhere because of being system being somewhat isolated or thermally insulated in this case. So the energies are just going to be remaining inside this chamber only. So if I use that fact, so I know definitely the final case will look like F by 2 P final volume final, which should be like F by 2 P1 V1 plus F by 2 P2 V2, right? And if I try to see the, okay, if I try to see that there are number of moles also given, everything as such is there in place. So can I say that it will be okay, just give me a second. volumes are there, pressures are there, and we know definitely that in this case the gases, their number of moles are also going to be present. Okay, why that will be required? Because there will be a issuance of this. Okay, the gases are assumed to be same, right? Because they are not giving any classified information about these. So I can definitely just go on to write this expression as, because V final I can write as V1 plus V2, whatever initial volumes were there. Because I know the volume in these cases were nothing but I think 2 liters and 3 liters. So I think 2 plus 3 will give me 5 liters as such total. And if I talk about the P final which is supposed to be found, so that is the part of the demand of the question. And if I talk about P1, it was nothing but P1 was I think it was 1 atmosphere, 1 atm. And if I talk about the volume one, it was 2 liters. So P1 V1 I can easily calculate from here, and P2 was given as 2 atm, and that was accompanied by volume equal to 3 atm, 3 liters, right? So this was 2 liters, this was 3. So if I just want to compute, and as the gas is not different here in this case, so these parts are just going to simply get deducted. So P final can be written as P1 V1 plus P2 V2 divided by V final, right? So if I write these numbers properly, can I say it will be 1 into 2 in this case and 2 into 3 in this case, that divided by the total volume was supposed to be 5. So that number is 2, 2 plus 6 is going to be 8, 8 by 5 is trying to take me towards 1.6. That is what we are expecting as the answer in this case. So I think, yeah, this is what, sorry, not this one, just a second. How do we do undo for this? Okay, undo this. Okay, so I think that is what I was trying to say as the final answer. So 1.6 atm is what we are expecting as the answer for this case. So let's just conclude the very first part of the 45 video question discussion here, and we'll be giving you such 3-4 lectures together to sum up all the 45 questions, so that you can get the answers also completely for such kind of questions, that how you are supposed to approach them. It's not about the answers here, so you should get the understanding also what you were supposed to think, right? So that was the main purpose of the video. So here we are here at Romutation Academy to always help you preparing for such exams. So currently we are focused on IIT JEE, but soon we will be up for all the NEET people also who are preparing, those who need help in physics, chemistry, biology, anything. So soon we'll be coming up for you. But for physics, chemistry, we are right now also available to help you out. So let's be connected, and all the best. Hope you are doing fine for in all the respect. Don't get boggled by the exam today. Just balance yourself and keep yourself calm. We'll soon be discussing all the other questions. Thank you.